All right, demo 07. All right, so the first question, we have two residual plots, and we're asked a bunch of questions about these. So the first one is plot A shows a violation of which one of the assumptions. So here we can see, increasing variability in the error term. So this is a violation of homoscedasticity. So this is heteroscedastic errors. So we can rule out all the other ones. And then for B, the appropriate fix for this issue would be what? So we know when we have this issue, we can address this using robust standard errors. So what we would do here is, just use robust standard errors. So if we had, a different kind of issue like this, maybe another type of fix would be to add a square term or some non-linearity in the regression equation. Okay, so this third question is if residuals show increasing spread with larger fitted values, this violates which assumption? So this looks like almost exactly the same question as A. So we can draw this. So if it looks like larger fitted values or larger spread with larger fitted values, then this would violate the same one. So this is sort of a duplicate question. Who wrote this exam? All right, so the second question, a labor economist analyzes the relationship between years of education, work experience, and hourly wages using data from 60 workers. Okay, so our sample size is 60. And then we have some regression results here. So some questions. We're asked to rate the estimated regression equation for this model. So if I'm just looking at this, we're trying to look at hourly wages. So we know we have wage is equal to something. And then we have these estimated coefficients and the variables themselves. So we have an intercept, which is just beta 0, plus we have our 1.23 times education. And then we also have experience, which is 0.45 times experience. And I guess I should have written this as the actual value. So 5.42. So here's our equation. And so we just need to check that against the options at hand. So the first one, we have wage is equal to this number plus this times education. So far looks good and still looks good. So that first one looks like a valid option. The second one looks like education should have a coefficient of 1.238 versus, so it just looks like these coefficients are flipped, so this is not it. Education, so we're not trying to predict education, we're trying to look at hourly wages. So you can tell this is, wages is the outcome variable because it's not included in this list. And then the last one, we do have wage, but looks like we're multiplying the beta 0 by the rest of this education component. So, well, even all of the components. So this is also not it. So the first one is the correct one. All right, so B, interpret the coefficient for experience in this model. So if I were to just say this in words without looking at the answers, or looking at the possibilities, we're asked to interpret the experience coefficient. So that's this last one. So if I were to say this, it would be something like for every additional year of work experience, we see wages go up by 0.45 dollars. So hourly wages go up by roughly 50 cents, and this is significant, all while holding everything else constant. So if I were to look at the options here, we would say each additional year of experience, we see hourly wage increases by, okay, this is looking good so far, holding education constant. So nice, this looks good. Second one, for each additional year of experience, hourly wages increases by this percentage. Well, here we're told that hourly wages are in dollars. So this isn't a percentage measure. But everything else about this is right. It's just that last bit isn't correct. Sometimes we talk about log values as the outcome variable, but here it's not percentage, it's just the actual value increasing. And then we're talking about some multiple times more important than education. That may be true, but or it may be true that it's some value more important, some fraction more important than education, but it's not this number. That number is not the interpretation. Okay, so then the last bit is the correlation between experience and wages is this. Well, this does tell us something about sort of the relationship between these two variables, holding everything else constant. We haven't mentioned holding everything else constant in this option. And this coefficient isn't exactly a correlation. So this is not the correct answer. So the first one is. Okay, so last question here. An education researcher wants to study whether student performances on standard tests differs between schools with different levels of per pupil funding. They have data on test scores and funding levels for 70 schools. All right. So the important bit here is we have student performance on standardized testing, and we have a measure of per pupil funding. And we have 70 schools. So which regression equation would be most appropriate to answer this question if the researcher wants to directly measure the relationship between funding levels and test scores? One way we could do this is, we're looking for an outcome variable. So on our vertical axis, we have test scores. And on the horizontal axis, we have funding. And so typically the way we think about this kind of question is to set up a model that looks something like this. So we have our beta 0, and then we have our slope and an increase of 1. And so this model would look like test score is equal to beta 0 plus beta 1 times funding plus our epsilon term. You could also think about trying to capture a relationship here, predicting funding using test scores, which would sort of be the almost like the inverse of this function. But this would be the standard way of setting this up. So to check this against the options, we have, well, the first one looks very nice. This later one, we're looking at funding is equal to some intercept term, and then we're trying to predict funding using test scores. This is one way of setting up that relationship where we have funding on the vertical axis and then test scores on the horizontal axis. This would allow us to measure the relationship between these two variables, but just from kind of an inverted way. So this is, this would probably have some partial credit, but this would be the better answer. All right, so the last one, the researcher fits a model and obtains a statistically significant positive coefficient for funding. So, we have some coefficient 1 and then a p-value, which we often talk about this being, less than 0.05. And then we say after checking the residuals, they notice a curved pattern rather than a random cloud. So maybe something like this for the residuals. This indicates what? So a couple of options here. This indicates there's a nonlinear relationship, but let's just check the options. The relationship between funding and test scores is nonlinear, so this looks like a good option. The model has better predictive power than expected, so this doesn't say anything about predictive power. The R-square value must be very high. Well, we haven't really even talked about R-square that much, and this wouldn't say that anyway. And the last one is there's no significant relationship between funding and test scores. Well, we've just established that there is an important relationship here, so this is also not right. So the first one would be correct. All right, so this is a pretty good indication of what to expect on MiniExam 7. I will see you all in the next one.